Exploring new insights into wet AMD, VEGF trap eye, a novel molecule under investigation. Recent therapeutic advances in wet age-related macular degeneration have focused upon an angiogenesis promoter, vascular endothelial growth factor A, known as VEGF-A. Inhibition of VEGF-A has led to delay in progression of visual loss in many patients, and in some patients, improvement in vision. Yet durable improvement in vision remains a clinical challenge in the majority of patients. Moreover, the frequency of regular office visits and repeat injections can pose limitations for patients and ophthalmology practices. New understanding of the role of VEGF-A and its complex interactions with other growth factors, such as placental growth factor or PLGF, another member of the VEGF family, has led to new insights into wet AMD and its management. Let's take a further look at new insights underlying the biology of neovascular or wet AMD. The majority of initial vision loss is caused by pathological choroidal neovascularization with resulting hyperpermeability and edema. Left untreated, hemorrhage of these abnormal vessels and fibrovascular scarring, which replaces normal macular structures, can result in profound and irreversible loss of vision. Damage to the central retina caused by the pathology of wet AMD is at the core of the resulting vision loss. The retinal pigment epithelium, or RPE, supports photoreceptor survival and renewal. The RPE, joined by tight cellular junctions, forms the outer blood-retinal barrier, which is essential to maintenance of normal retinal environment and fluid balance. When extracellular material is deposited and drusen are formed, the intimate relationship between the retina and choriocapillaris, its vascular supply below, is disrupted, resulting in hypoxia and metabolic stress. This compromises the structural integrity of Bruch's membrane and the overlying RPE, disrupting the normal microenvironment of the retina. Increasingly severe hypoxia and metabolic stress also stimulate the production of cytokines and angiogenic factors, including VEGF-A and PLGF. This results in the abnormal growth of fragile new vessels between Bruch's membrane and the RPE, or within the retina itself, leading to the sequelae of wet AMD exudation, hemorrhage, and edema. VEGF-A isomers, including 121 and 165, are at the center of the wet AMD pathobiology. The biologically active dimeric forms of these growth factors have a receptor-binding interface at each end. VEGF-A dimers bind to VEGF receptors 1 and 2. Activation of pro-angiogenic pathways result in proliferation and migration of vascular endothelial cells and the formation of ectopic, fragile, and highly permeable blood vessels, which are the key elements in the pathology of wet AMD. Although its precise role continues to be investigated, recent research also suggests a role for PLGF in promoting pathologic angiogenesis. PLGF binds to the VEGF receptor 1 and may stimulate angiogenesis directly by activating the receptor. Alternatively, PLGF may also compete with VEGF-A for binding to VEGF receptor 1, allowing VEGF-A to bind to VEGF receptor 2 and stimulate angiogenesis. PLGF may also act as a chemoattractant for inflammatory cells through VEGF receptor 1, increasing their migration into the diseased retina and the release of VEGF and other inflammatory mediators. This further reinforces the cycle of angiogenesis and inflammation initiated by the increased local production of VEGF in wet AMD. VEGF trap eye, a biologically engineered protein, is under clinical investigation in wet AMD. VEGF trap eye comprises portions of the extracellular ligand binding regions of native VEGF family receptors, namely VEGF receptor 1 and VEGF receptor 2. By fusing the key binding domain from the human VEGF receptor 1 with a key binding domain of human VEGF receptor 2, tight binding affinity for both VEGF-A and PLGF is achieved. Two dual-domain arms are then fused with the Fc portion of a human immunoglobulin G antibody, mimicking the natural receptor necessary for high-affinity binding of dimers. Therefore, VEGF trap eye binds active dimers with high affinity in a precise 1-to-1 ratio, like two hands clasping a ball. In addition to VEGF-A, VEGF trap eye also binds PLGF. VEGF trap-I binds both growth factors with high affinity, higher than the affinity of these ligands for their natural receptors, as characterized in the literature for VEGF-A 121, VEGF-A 165, and PLGF. Thus, when bound to VEGF trap-I, the VEGF dimers cannot activate their cell surface receptors on the vascular endothelium, thereby inhibiting a key angiogenic signal. Studies are underway to determine the clinical relevance of the pharmacologic properties of intravitreally administered VEGF trap-I, namely the ability of VEGF trap-I to bind both VEGF-A and PLGF with high binding affinity. Regeneron Pharmaceuticals and Bayer, global development partners for VEGF trap-I, are committed to advancing the management of wet AMD to help address patients' and ophthalmologists' unmet medical needs.